Okay, so we're going to take a look at number 21 through 30 on the chapter 2022 math counts. Now, I know the sound isn't going to be great, so bear with me, but let's see what we got. All right, so for 21, James is making a sandwich with 2 slices of bread chosen from rye, wheat, and white, and filled with either ham, cheese, or both. If his sandwich can have 1 or 2 types of bread in the order of the ingredients does not matter, how many different sandwiches can James make? All right, so here's the thing. We know that a sandwich can have either rye, and that is not the right color. Oh boy, don't you hate when that happens? So we can either have rye, wheat, or we can have white. So that's 3 different combinations, but hold on a second. We can also have rye, 2 slices of rye, 2 slices of wheat, 2 slices of white, but we could also have rye with wheat, rye with white, and white with wheat. So that gives us a total of 3 different options right there. And so we also have, 3 plus the other 3, so we have 6 different bread options. And then we have ham and cheese, or we could have ham and cheese. So that gives us 3 more options. 3 times 16 is 18. So there are 18 different sandwiches that we can get. All right, so number 22. On Wednesday, 1/3 of the students in Mr. Short's homeroom had drama class. I'm going to write this. So 1/3 have drama. And then 1/4 of his remaining students had band. So then 1/4 of the remaining students had band. And we know that we had 6 students who went to band. Well, if 6 is 1/4 of the whole, that means we had 24 total kids once the band kids took a hike. Well, okay, we had 1/3 of the people previously leave, which means that this number here is 2/3 of the total. Well, 2/3 of the total, that means half, 12, of the total of the 24 had to go to, drama. So that means we had 36, because 36, what's 1/3 of 36? Well, 12. So that gives us our 24, and then 1/4 of 24 is 6. There we go. The answer is 36. Should probably check to see if I'm right, but oh well. Okay. Number 23. Clear that. Let's scoot down. Oh my goodness gracious. That is a lot of reading. Who thought this was going to be okay? This is supposed to be a math competition, not a reading competition. All right, so the important thing here is the blah, 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 blah. We know that an accelerator does a step based on this 3G. So we have 1, 2, not that one, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's a tricky one. 16, 17, 18. We have 19 total steps that your phone is going to record. And we know that each step is going to be 114 centimeters per stride. And so we want to know what was Jen's average walking speed in meters per second over 20 seconds. All right, so at first I was really super tempted to multiply 140 and 19, but wait a second. I know I'm just gonna have to divide stuff later, right? So, okay. So here's what I'm gonna do. So we have this thing in centimeters, and we need our answer in meters per second. So let's turn this into meters. Well, that's going to be equal to 1.4 meters per stride. So that means we have 19 times 1.4, but then we're dividing it over the 20 seconds. And remember, we want meters per second, so that's what we're going to get. Now, I'm looking at this, and 20 doesn't really go into anything, so, man, I really would like to make this work a little bit better. So, well, I'm looking at that 14. Well, that's an even number, right? So here's what I can do, which is super convenient. I know that 2 divided by, or 1.4 divided by 2 is going to be 0.7. 0.7 divided by 10 is going to be 0.07. And so that cancels that out right there. And so then we still have the times 19. So now all I have to do is multiply 19 times 7. So 7 times 9, well, that's just going to be 63, right? So carry the 6. So 7 times 1 is going to be 7, plus 3 is 13. And then the question is, how many decimal places do I need? Well, I have 1, 2, so that means the decimal place goes here. So I have 1.33 meters per second, and it says round to the nearest hundredth, 0.33. All right. Number 24. A triangle has integral or integer side lengths. It means that we need whole numbers. Integers are whole numbers. And we know that 2 of the lengths are 2, 5, and then something that's an x. And we want the median, the middle number of all of the possible values of x. So one thing I know is in a triangle, if I call this small, medium, and large, I know that the small plus the medium has to be greater than the large. So that's the piece of information I need to remember about triangles, right? So that means that, what does that mean? Well, that means that x has to be greater than 2 plus, sorry, my bad. X has to be less than 2 plus 5, right? So can x be 7? Well, not so much. But then, well, wait a second. That's assuming that x is the longest side. Well, what happens if x is the shortest side? Well, that means that x has to be greater than 5 minus 2. So that means x has to be greater than 3. So that gives us 4, 5, 6, and that's about it. Well, what number is in between, or what's the median number there? Well, clearly it's 5, right? It's the middle number, so we got 5. All right. PixFlix, not Netflix, PixFlix. Online video charges $5.95 to view a movie. Movie Prime, not Amazon Prime, Movie Prime, video services charge $150 per year, plus $3.95 per movie. Assuming that Minda views the same number of movies each month, what is the fewest number of movies per month that Minda must view in order to make Amazon Prime, Movie Prime, the better deal? All right. So, first things first, we've got 2 different units. We've got years in the membership fee, and then we have months, how many things per month. So the first thing I really kind of want to do is I want to turn this $150 per year into dollars per month. So 150 divided by 12, because there are 12 months in a year. All right, so, well, you know, how many times it goes in, right? So 12 goes into 15 exactly once. Carry the 3. 12 goes into 30 twice. And so that gives me a remainder of 4, right? So 12 goes into 40. How many times? Well, it goes in 3 times. I feel like I'm going a little bit off the reservation here. So 5, let's carry the 3. So 12 times 2 is 24. Oh, that's 6. Duh. All right. So how many times does 12 go into 60? Well, it goes in 5. So that means we're at $12.50 per month for the membership fee. All right, great. So how much do you save? How much do you save so that you are how much, sorry, I totally lost my train of thought. How much do you save per movie? Well, I noticed that this is a difference of 2. So that means every movie that I rent, I save $2 from the movie Prime Video. So, okay, well, great. So how many movies do I need to watch to surpass this $12.50? Well, that's 7. I have to watch 7 movies, because then that 7 movies per month will save me $14, which is more than 12. All right. All right, so let's look at number 26. All right, oh, this is a cool rules of exponent problem. The number 345,600 can be expressed as an 6 to the A, 5 to the B, and 4 to the C for integers A, B, and C. So A, B, and C are integers. I'm guessing we're gonna have to have some, well, probably some negative. I don't know, we'll find out. What is the product? You can't stop yawning. Oh my goodness, that's no good. What is the value of the product of A times B times C? All right, so here's what I'm gonna do. I'm not gonna go full on prime factorization because, well, I mean, I'm looking at 6s, 5s, and 4s. So, all right, the first thing I'm going to do is, I notice that this number is divisible by 100. So I know that 3, 4, 5, 6 times 100, well, that's going to get me my number, right? And I know that 100 is 10 times 10. Well, that just is 2 and 5, but I have 2 of those because I have 2 10s. Well, let's take a look at this number. All right, so, okay, what goes into this number? Well, 56. Well, 56 has a 4 in it, right? It also has, well, 3 plus 4 plus 5 plus 6, so that's 18. So it has a 9 that goes into it. So well, let's go with the 9 because that's a little bit bigger than 4. So 9 goes into 34. How many times? 9 goes into 34. Oh shoot! But wait a second. 9 doesn't help because there are no 3's, right? So I want 4. So I want to keep with 4. So 4 goes into 34 8 times. Carry the 2. 4 goes into 25, a total of 6 times, carry the 1. 4 goes into 16 4 times. All right, so 4, okay, 4 is cool. I like 4 because we have 4 here. I guess the 2 isn't so cool, but 2 squared is just 4. So now I have 2 4s, so 4 times 5, okay, we're good. All right, so looking here, I think 4 goes into this again. So 4 goes into 8 twice, 4 with no remainder. 4 goes into 6 once with a remainder of 2, and then we get a 6. All right. So then looking at this number, I feel like we need to have, we do need to have some 3's, right? Because 6 is 2 times 3, right? So let's bring back that 3. I guess I wasn't wrong in the first place talking about the 9, right? So we have 16 and 9. So 9 goes into 21 exactly twice. Carry the 3, 4. All right, that's good. Now 9 9 is 3 times 3, right? So these two of these 3's can hook up with 2 2's to get me a 6, right? So then 24 has a 6. 6 and a 4. All right, so that's I like the 6 and a 4. All right. I guess it would have been easier just to divide everything by 6 over and over and over again. Oh well, whatever. All right, so I have 1, 2, 3, 4. I have 4 4's, and then I have 2 3's. But I'm gonna have to do something with it. I have to link those 3's somehow. I have 2 5's. I have 5 to the second. All right, so then the question becomes, oh, and I don't have 3 3's. I have 2 3's. 2 3's, right? All right, so 2 of these, oh, and I have the 6 to the first, right? 2 of these 3's can link with 2 of those 4's to make a 6, right? So that gives me 6 to the third, because 2 plus 1 is 3. That makes this 2. So I have 2, 2, and 3 as my exponents. So 2 times, oh, bugger. Where did I go astray? All right, I figured out what I did wrong. All right, so here's what I did wrong. 4 is 2 times 2, right? So each one of these 2's corresponds with those 3's, right? So really, I'm only getting rid of 1 4, not 2 4's. So that gives me 4 to the third. I'm sorry about that. 4 to the third times 5 to the second times 6 to the third. 3 times 3 is 9. 9 times 2 is 18. Oh my goodness. So it's kind of funny. So I did this problem at home. No problem. Only when I'm in front of a camera is when I make a mistake. All right, so here we go. Sorry about that. Number 27. Kurt Siebold is creating a bouquet of flowers for his mom. He has chosen a selection of roses, lilies, orchids, and violets from which to create a bouquet of a dozen flowers. Kurt's mom loves orchids, so his bouquet will have at least 6 orchids. How many different groups of dozen flowers can Kurt use in the bouquet? All right, so I gotta admit, I learned something new on this one. So here's what I did. I went ahead and gave myself a dozen blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I know that at least 6 of them have orchids. Well, that leaves another 6, right? And so I could have more than 6 orchids. So then what the next thing that I did was I said, okay, so I could have, well, if I have the orchids here, I have roses, lilies. I like Asiatic lilies. They're kind of cool, and violets. So if I have just 6 here, then I could have, well, I could have 6, 0, and 0. Or I could have, and then that could be, you know, I could do it 3 times by moving the 6 over. I could do 6, 1, 5, 0, and then I could move things around, but then I'm like, dude, this is gonna take bloody forever. I'm not gonna be able to do this in a shorter period of time. So I'll admit to it, I looked things up. So then I found this thing called the bar and spaces method. And so here's what we have. So we have the orchids, all right? And so I'm gonna have some spaces. I'm gonna call this roses. And I'm going to call, sorry. There's another bar. So I'm going to call this roses. I'm going to call this lilies. And then let's call this one, what's it called? violets. So what I have here, and I could have different combinations by moving the bars around. So what I have here is I have 8 orchids. Why do I have 8 orchids? Well, because I have the 6 orchids already. Plus I have these 2 over here. Well, how many roses do I have? Well, I have no roses in front of this, so therefore I have 0 roses, and I have 4 spaces in front of the lilies, so this has 4 lilies, no violets, and 8 orchids. And I can move these bars around. So if I move this bar, say, oops, let's say I move this bar. Okay, one more time, third time's a charm. Let's say I move this bar over 1. So now this is saying I have 0 roses, 4 lilies, 1 violet, and 7 orchids. And so I can move this around. So now I have, my goodness. So now I have 1 rose and 3 lilies. Which is kind of a cool way to look at it, but it has an added benefit, and that added benefit is it gives me some combinations. And you'll remember that oh my gosh, that's going to give you a right there. So combinations, we have n times r, which is equal to n factorial over n minus r factorial times r factorial. And so in this case, the cool thing about the bars and the spaces is all I have to do is add up the empty spaces and the bars that I'm using, and voila, I have my n value. So that means that I'm looking for the combinations of 9, that's 3 plus 6, and 6. All right, well, that's doable. So I have 9 options, choose 6 of them, so that's not too bad. So this is going to be equal to 9 times 8 times 7, but I don't have to write the 6 factorial because the 6 factorial gets canceled out by the r factorial in the denominator. But I still have my 9 minus 6, that's 3, so I'm going to put the 3 here, I'm going to put the 2 here. This 3 cancels out a 3 of the 9, so that means I have 3 times, well, that breaks out the 4, 3 times 4 times 7, so 21, if 3 times 4 is 21, 21 times 4, that's just 84 options. So that bar and space method is pretty cool. I've never seen that before, so it's kind of fun when I get to learn something new too. All right, so then for number 28, if 3 over x plus 2 is equal to y plus 3 over 2, and x and y are integers, which makes life really easy for us. It means that they have to be whole numbers. That eliminates an infinite number of answers, literally. What is the sum of all the possible values? Now, you may remember from way back in 7th grade, maybe even 6th grade, when you learned how to do cross multiplication. So I have a ratio is equal to another ratio. It's called a proportion. They're equal. So, okay, cross multiplication. So this means I multiply across the equal sign. So that means 6 has to be equal to x plus 2 times y plus 3. All right, so that's really, really helpful. So that means I have 2 numbers that I'm multiplying together, and when I multiply them together, I get 6. Oh, well, okay, wait a second. So that means this thing here, if this thing here is equal to 1, that means this piece here has to be equal to 6. If this is 2, this has to be 3. But wait a second, it's really tempting to just stop at those 4, or 2 pairs. A negative times a negative is also a positive. So that means that -1 and -6, -2 and -3. And obviously I can swap them, right? So I could have over here, I could have 6 I could have 6 over here, 1 over here, 3 over here. So really, I have how many different options for this piece right here? Well, I have 8. So it's tempting to say, but wait a second, if I add up all these numbers, notice how I have opposites, right? 1, negative 1, 2, negative 2, 6, negative 6, 3, negative 3. So the sum of all these values is 0. So I'm really tempted to write 0, but then I realize, wait a second. X doesn't have to equal 1, 2, negative 1, negative 2. X plus 2 has to be equal to that. So that means X has to be 2 less than each of these numbers because I'm adding 2 to X. Well, okay. So that means for us to get a 1, X has to be negative 1. And for us to get a 2, X has to be 0. And for us to get a negative 1, X has to be negative 3. This has to be negative 5. Oh my God. Negative 2. Because I teach math, I add and subtract numbers. Oh my God, that's negative 4. Because negative 4 plus negative 4 plus 2 is negative 2. For us to get a 6, we would have a 4, right? Because 4 plus 2 is 6. That would give me 5. This would give me negative 8, right? Because negative 8 plus 2 is negative 6. And this would give me negative 5, because negative 5 plus 2 is negative 3. And so now we need the sum of all those numbers. All right. So, excellent. I don't really want to add those together, but, you know, whatever. Here we go. So, ew, I don't really want to write those or add those together. So 4 plus 5 is 9. Oh, but better yet, I mean, this 5 here crosses off this negative 5. This 4 cancels out this negative 4. So really, I just have negative 8 plus negative 3 plus negative 1. That gives me a grand total of something is, oh my goodness, I need to eat. I am so hungry. All right, so what happened here? Oh my goodness. This is what happens when you don't eat lunch and you're in the middle of a migraine and you can't think straight. 3 minus 2 is not 5. 3 minus 2 is in fact 1. Man, this whole math stuff would go so much better if I could actually add and subtract, right? So now we can cancel things out. So this, all right. So this 1 cancels out with this negative 1. This negative 4 still cancels out with this negative 4. We still have our negative 5 because I'm an idiot. So negative 5 plus negative 8, well, that's negative. Well, watch me make another mistake here. That's negative 13. Negative 13. So that gets us negative 16. Is that right? That is right. Look at that. So the answer is, in fact, negative 16. Sorry about the confusion. I'm, again, just struggling today. All right. Last two. All right. We're getting there, folks. A sequence. These are the two long ones. So, you know, I'm going to make another video so that this doesn't get ridiculously long. Maybe it is already ridiculously long.